What really happens inside a black hole? Scientists believe the laws of physics begin to break down beyond the event horizon, a point where nothing, not even light, can escape. Time slows, gravity becomes infinite, and space itself bends into something we still can't fully understand. Some theories suggest black holes could lead to other universes, while others say everything is crushed into a single point called a singularity. But the terrifying truth is, no one has ever seen what's inside, and maybe no one ever will. Today we will talk about what happens inside a black hole. So before we start, make sure to hit the like button and subscribe to my channel. 1. The birth of the universe's darkest object. A black hole is one of the most terrifying and mysterious objects in the universe. It is a region in space where gravity becomes so powerful that nothing, not even light, can escape once it crosses a boundary called the event horizon. Most black holes are born when a massive star reaches the end of its life. After burning billions of years of nuclear fuel, the star can no longer fight against its own gravity. The core collapses inward at unimaginable speed, creating a violent supernova explosion. What remains afterward is a tiny point packed with enormous mass. This collapsed core continues compressing until gravity crushes matter beyond known physical limits. Scientists believe this process forms a singularity, a point where density becomes infinite and the laws of physics begin to break down. 2. Crossing the event horizon. The event horizon is often called the point of no return. Once anything crosses this invisible boundary, escape becomes impossible. To an outside observer, an object falling into a black hole would appear to slow down as it approaches the event horizon. Time itself begins behaving strangely because of extreme gravity. According to Einstein's theory of general relativity, gravity bends space-time, and near a black hole this effect becomes extreme. As the falling object gets closer to the event horizon, its light becomes redder and dimmer until it eventually disappears. However, from the perspective of the person falling in, time feels completely normal. They would pass through the event horizon without noticing any magical wall or barrier. 3. Spaghettification. The most horrifying stretch in the universe. One of the most horrifying effects near a black hole is called spaghettification. This occurs because gravity near a black hole changes drastically over very small distances. If a person fell feet first into a stellar black hole, their feet would feel much stronger gravity than their head. The difference in gravitational pull is called tidal force. These forces would stretch the body vertically while compressing it horizontally, slowly turning the person into a long, thin strand resembling spaghetti. Bones, muscles, organs, and even atoms could eventually be torn apart. The closer one gets to the singularity, the more extreme the stretching becomes. In smaller black holes, this process would begin even before reaching the event horizon. In supermassive black holes, however, the event horizon is much larger, meaning a person could theoretically cross it before tidal forces become fatal. Even so, survival would still be impossible because the singularity waits deeper inside. Scientists calculate that near certain black holes, gravitational differences could exceed billions of times Earth's gravity. 4. The mystery of the singularity. At the center of every black hole lies the singularity, the most mysterious point in the universe. According to Einstein's equations, the singularity is infinitely small and infinitely dense. Every bit of matter swallowed by the black hole is believed to collapse into this point. However, infinity in physics usually signals that a theory is broken down. General relativity describes gravity extremely well on large scales, while quantum mechanics explains the behavior of particles on tiny scales. But inside a singularity, these two theories conflict violently. Scientists do not yet possess a complete theory of quantum gravity capable of describing what truly happens there. Some researchers believe the singularity may not actually exist. Instead, the center of a black hole could contain exotic quantum structures, compressed energy states, or unknown forms of spacetime. Other theories suggest black holes may connect to wormholes, hypothetical tunnels linking distant parts of the universe. Some even speculate that the interior of a black hole could create an entirely new universe. 5. Time distortion inside a black hole. One of the strangest phenomena associated with black holes is extreme time distortion. Einstein discovered that gravity affects time itself. The stronger the gravitational field, the slower time passes relative to distant observers. Near a black hole, this effect becomes enormous. Imagine two identical clocks. One remains far away in space while the other approaches a black hole. The clock near the black hole would tick far more slowly. For the falling person, however, their own time feels normal. This means black holes can act almost like natural time machines. Into the future, if someone orbited near a black hole for a short period and then returned to Earth, they might discover that decades, or even centuries, have passed outside. This concept was famously explored in the movie Interstellar, where a planet near a black hole experienced 1 hour equal to 7 Earth years. Although dramatized, the science behind gravitational time dilation is real. Deep inside the event horizon, the structure of space-time changes so drastically that the roles of space and time may effectively switch. 6. Hawking radiation and black hole evaporation. For many years, scientists believed nothing could ever escape a black hole. But in 1974, physicist Stephen Hawking made a revolutionary discovery. By combining quantum mechanics with black hole physics, Hawking proposed that black holes slowly emit radiation, now known as Hawking radiation. According to quantum theory, empty space is not truly empty. Tiny particle-antiparticle pairs constantly appear and disappear everywhere. In a vacuum of space, near the event horizon, one particle can fall into the black hole while the other escapes into space. To distant observers, it appears as though the black hole is emitting particles. Over incredibly long periods, this process causes black holes to lose mass and slowly evaporate. Small black holes evaporate faster than large ones. A stellar black hole may take far longer than the current age of the universe to disappear completely. Supermassive black holes could survive for trillions upon trillions of years. Hawking radiation created another major scientific puzzle because it suggests black holes can eventually vanish entirely. 7. Could black holes be gateways? Some theories suggest black holes may not simply destroy matter forever. Instead, they could serve as gateways to other regions of spacetime. The idea of wormholes emerged from solutions to Einstein's equations. A wormhole could theoretically connect two distant points in the universe, or even different universes entirely. In science fiction, wormholes are often portrayed as shortcuts for faster-than-light travel. Some physicists speculate that black holes may contain wormhole-like structures inside them. However, there is currently no evidence proving stable wormholes exist. Most mathematical models suggest wormholes would collapse instantly unless supported by exotic matter with negative energy. Other theories propose that black holes could create white holes, hypothetical objects that eject matter instead of absorbing it. In this scenario, matter falling into a black hole might emerge elsewhere through a white hole. There are also speculative ideas suggesting our own universe could exist inside a giant black hole formed in another universe. But if you like this video and would like to see more like it, please give it the thumbs up, leave a comment, and click the button to subscribe.